Hello everybody, welcome to the video. We're going through numbers 6 to 10. So number 6 asks us to solve the triangle. Now I don't know if this triangle is a right triangle, and I'm going to assume it's not, which means I have an oblique triangle, which means I need to use either law of sines or cosines. And the best way we can determine if law of sines or cosines is appropriate first is to use a triangle and label it appropriately. So we have triangle DEF, and I'm going to put in here what I know. I know that angle D is 40 degrees. I know that side F across from angle F is 7 inches, and I know that side D across from angle D is 26 inches. Now, you can clearly see that this triangle may not be accurate. The 26 may be the largest side, but kind of go with me here. So what we need to decide is if the law of sines is appropriate. And law of sines is useful whenever you see one of the following. If you see angle, side, angle, if you see angle, angle, side, if you see side, side, angle. Any of these three denotes that you are going to use the law of sines. These two, because whenever you have an angle directly across from a side, like we do here, or having more than one angle, usually means that the law of sines is more helpful at the beginning. But what we have in this situation is angle, side, side. So we have the ambiguous case, which means that we could have two triangles, 1 or 0. So what we need to do is originally assume that there's 2, but you could possibly prove that there might only be 1. So we need to start with the law of sine, because it does apply, because I have enough information. We can say sine of 40 degrees over 26 is equal to sine of angle F over 7. And if I cross multiply, I get that the sine of F is equal to 7 times the sine of 40 all over 26. And so if I plug that into my calculator, just so we can communicate over video here, 7 times the sine of 40 degrees divided by 26, you would get sine of F equals 0.17305 and so on. To get F alone, you have to take the inverse sine of 1.7305, If you do that in your calculator, I got the angle F to be 9.97 degrees. Now, because this is the ambiguous case, we may have to assume that there are two triangles and try to prove one wrong. So over here, I have to do a second option. If I have angle F, which is an acute angle, we might also have an angle F prime, which is found by doing 180 degrees minus 9.97 degrees. The reason that's true is if I draw just a general oblique triangle again in this case, and we know this angle, we know this side, and we know this side, I have no idea if this angle is acute or obtuse. So we need to think about both options, and to find the obtuse angle, we just take the supplement. And if I did that, I would get F prime to be 170.04 degrees. And so let's look at both options. Option 1. The problem gave me originally that I have 7, 26. I have this angle is 40 degrees, and I just found that angle F here was 9.97 degrees. If I add these up, this sum is definitely less than 180, so this is definitely a triangle. So I can keep going here. This one, if I draw a brief picture, and I label that DEF, and I look at just the angles really, I have originally that this angle is 40 degrees, and I just found that F is possibly 170.04 degrees. If I add up 40 and 170, that is way over 180 degrees, which means that this third angle would be negative, which is impossible. So I assumed that there were two triangles. There aren't, so there's really only one. So we're just going to keep going on this one. We found that angle F was 9.97. The only angle that we don't have is angle E. So angle E would be 180 degrees minus the angle we just found minus the 40 that was given originally. So that would be 130.04 degrees. Then the last thing we'd have to find is the side we don't know, which is side little e. And so we could use the law of sines again. And so I just found this was 130.04 degrees, and I'm trying to find this. So I could say sine of 130.04 degrees over the side I don't know equals, let me go with the one was given me originally, sine of 40 degrees over 26. So in the calculator, you eventually would have that E is equal to 26 times the sine of 130.04 degrees divided by the sine of 40 degrees, which would be 30.97, what was my original unit? Inches. So we've officially solved the triangle that exists because we found the missing side and two missing angles. Number 7, if I draw this one as well, this time we have triangle RST. I'll label it the same way. Again, just go with my picture. If it's not perfect, then that's still okay. We have angle R is 16 degrees. We have that side across from angle T is 11, and side across from angle R is 8. So just like last time, at the beginning of the problem, it looks like I have angle, side, side. So again, I have the ambiguous case. So what we need to do is assume that there might be two triangles at the beginning of the problem, because again, we don't know if this angle is acute or obtuse. So let's again start with the law of sines. I know I can apply that because I have an angle right across from a side. So I could do sine of 16 over 8 equals sine of t over 11. If I cross multiply and solve, I would get sine of t equals, let's see, 11 times the sine of 16 divided by 8 would give me 0.379 blah blah blah. If I take the inverse sine of both sides, I would get an angle of 22.27 degrees. So that is one possible answer. But again, right here, we need to assume that we could have another possibility. So if I want to find the obtuse possible angle, I would do 180 minus 22.27 degrees. And if I did that, I would get the supplement of 157.73 degrees. And so this is the point that you want to draw two pictures and see if either triangle could make sense. So if I have RST, I've given 16 degrees. I just found that this was 22.27. This sum is less than 180, so this one looks like we're good to go. This possibility, we still have 16 originally. We found that angle T is 157.73. And what's interesting this time is if I add 157.73 to this angle 16, I get 173.73, which is underneath 180 degrees. So this also is a possibility for a triangle. So here's where the ambiguous case is really truly ambiguous. We have two possible solutions. We have to completely solve both here. So if I went with option 1 and I continued solving this, I found T, I have R, so angle S would be 180 minus 22.27 minus 16. So angle S would be 141.73 degrees. So I have the two unknown angles solved for. If I would like to find the unknown side, which this is 11 and this is 8, I just found that this was 141.73. We could use the law of sines. Sine of 141.73 over the side I don't know equals sine of 16 over 8. If I cross multiply and solve this, I get that the missing side was 17.98. What is my unit? Inches. Option 2, I have that T prime is 157.73, which means I need to find S prime. Let me put primes on all of these here. So S prime is 180 degrees minus 16 minus 157.73. So S prime is going to be very small. It's 6.27 degrees. Which means if I would like to find my unknown side, so this is T prime, S prime, my unknown side, because I just found that this was 6.27, would be sine of 6.27 over my unknown side equals sine of 16 over the this length here, which we got was 8. So similar to what we just did down here. If I cross multiply and solve this, you would get that this side is 3.17 inches. Number 8, given triangle ABC, okay. ABC. I know that the side across from A is 10 centimeters, the side across from B is 9 centimeters, and the side across from C is 3 centimeters. So it looks like this time I'm given side, side, side. So the question is, just like the last two, can I apply the law of sines? And the answer is no, because I do not have an angle across from a side. So I have to instead apply the law of cosines, which means I can pick any side I want to find first. My suggestion is whenever you don't know where to start, I would always find the largest angle first. The reason for that is it avoids that ambiguous case we were just working on. So if I want to find the missing side, the law of cosine states this. The missing side is a squared plus c squared minus 2 times the two sides you have on this side times the cosine of a. And so we would plug in what we know. Side A is 10 squared, side B is 9 squared, side C is 3 squared minus 2 times 9 times 3 cosine of I don't know. So my suggestion would be doing this completely in the calculator. If you would like to get cosine A by itself, you would take 10 squared. You would then subtract 9 squared minus 3 squared to the other side. Move these two guys over here. And then, to get cosine A by itself, you would have to divide by negative 2 times 9 times 3, because all of these are currently multiplying cosine A. And so, if you did that, you would get cosine of A is equal to negative 0.185 and so on in the calculator. You would have to take the inverse of both sides again because you're trying to find an angle. I would keep this all in your calculator, don't round too much. The angle A should be 100.67 degrees. Luckily for us, this is not the ambiguous case, so we don't have to try two triangles. And so we would just keep going with this one. We found that A is 100.67. So if I'd like to find the next angle B, because I have an angle across from a side now, I can use law of sines if I want to. So in this little box, I'll continue to find angle B. So that could be sine of 100.67 degrees over 10 is equal to sine of B over 9. If I cross multiply and solve this, and I'm just going to tell you what the answer I got B is 66.32. Feel free to pause the video and check to see if my cross multiplication is correct. If you then would like to find angle C, it would be 180 minus the 66.32 from up here, minus the 100.67 from over here. And so C would be 13.01 degrees. So there's solving the triangle, finding all the missing parts we did not have originally. So guys, instead of rushing to get the next two word problems done in a minute and 30 seconds, I would rather just do them on the next video. So please join me on the next one. Thank you.